Greetings of the day, dear students. In this video, we are going to discuss about the generation of rotating magnetic field, and we will see the equations for the flux phi of all the three phases. Let it be phase 1, phi 1, phi 2 and phi 3, right? What is its mathematical form representation, and also we will calculate the resultant value of the flux at any given instant. That is important. At last we are going to find out that the resultant value of the flux will be 3 by 2 phi m will be equals to the 3 by 2 phi m, that is 1.5 times the maximum value of the flux due to any one of the phase. So we will see step by step how we used to get that 3 by 2 phi m right in this video. Now as and when the stator is given or the three-phase supply, right, let it be phase 1, phase 2 and phase 3 or R phase, Y phase and B phase, because of the each individual phase the flux will be generated. Now the flux generated due to phase 1, let it be phi 1, and which is mathematically represented as phi 1 will be equals to phi m sin omega t. Similarly, the flux generated due to the second phase, let it be phi 2, it is mathematically represented as phi 2 equal to phi m sin of omega t minus 120 degrees. So phi 3 equals to phi m sin of omega t minus 240 degrees. So these mathematical equations itself represents that the flux is displaced by 120 degrees apart from each other. That means the angle difference between phi 1 and phi 2 is 120. Similarly, the angle difference between phi 2 and phi 3 will be 120. Similarly, between phi 3 and phi 1 also will be 120 degrees. Now, because of these three individual fluxes acting at a time, the resultant flux phi r at any instant will be equals to the vector sum of the individual fluxes. This is important. In this entire discussion, we are supposed to calculate what would be the vector sum of all the individual fluxes acting at a time at particular instant. Instead of calculating for each and every degree in the span of 0 to 360 degrees, we will focus what will be the resultant values at a different instants. For example, what will be the value of resultant flux at omega t or theta equals to 0. At this instant, the flux value due to phase 1 is 0. What we have to do is, in this equation, phi 1 is given by, at any instant is given by phi m sin omega t. In this equation, simply substitute omega t equals to 0 degrees. Then what will happen? Phi 1 will be equals to how much? Phi m sin 0. Sin 0 is 0. We will get phi 1 value is equals to 0. Similarly, at the same instant, what is the value of phi 2? What is the value of phi 2? This is the value of phi 2. What is the value of phi 2? That is obtained by substituting omega t equals to 0. So phi 2 equals to phi m sin of 0 minus 120. We will get the value as minus root 3 by 2 phi m. Minus root 3 by 2 phi m, right? Similarly, phi 3 equals to phi m sin of omega t minus 240. Phi 3 equals to phi m sin of 0 minus 240. We will get plus root 3 by 2 phi m. Now what will be the value of our important discussion is what is the value of resultant flux. It is not simply adding phi 1 plus phi 2 plus phi 3. We should not do like that. It is the vector sum. It is the vector sum of all the individual fluxes. It is the vector sum of all the individual fluxes. So how do you understand that? For example, if you are having some two vectors A and B, its resultant value R is given by what? Using the parallelogram law. Using this R will be equals to root over A square plus B square plus 2AB cos theta. Now already we are having phi 2 value as minus root 3 by 2 phi m and phi 3 as root 3 by 2 phi m. Now the resultant value will be how much? For example, here you can observe phi 2 value we are having minus phi 2, and flux 3 is having a positive value, and this is our resultant flux. Now the angle between phi 2 and phi 3 is how much? 60 degrees. The angle between phi 2 and phi 3 is how much? 60 degrees, right? So here, for example, I will make you one point clear. At this point, if this is phi 1, and if this is phi 2, and this is phi 3, then its quite opposites will be the negative values, right? So how do you understand that? If this is phi 1, it's quite opposite. Now this value will be minus phi 2, and it's quite opposite, anti-parallel, quite opposite. This value will be minus phi 3, right? Now here, if you want the resultant, already you know this angle is, the angle between these two is 120 degrees. So here this angle will be how much? Already this angle is 120 degrees. Out of this is 180. Out of that, 120 is already completed. Now this angle between minus phi 2 and phi 3 will be how much? 60 degrees. That angle will be 60 degrees. If you want the resultant, what we have to do is, for phi 3 opposite we will draw like this, and for minus phi 2 we will draw like this, right? And the resultant will be this value. This is the resultant flux. Like this we have to calculate. That is what we have done here. At theta equals to 0, this is the equivalent diagram. Instead of drawing all those things, only we have taken the minus phi 2 plus phi 3. The angle between those two is 60 degrees. Right, clear? So it's very simple. First take down the phi 1, phi 2, phi 3, and the angle between each two will be 120 degrees. Between any two will be how much? 120 degrees. If you want to calculate the resultant, you have to take its depending upon the context here. At what angle we are calculating? Here at phi 2 is a negative value we got, minus we got. Phi 3 is a positive value, right? So phi 2 negative value means like this we will extend back side, and like this we will extend parallel to the third phase, and we will, this one will be the resultant value. Now using this parallelogram, resultant value is phi 2 square plus phi 3 square plus 2 phi 2 phi 3 cos of the angle between those two, 60 degrees. So root 3 minus root 3 by 2 whole square phi m square plus minus root 3 by 2 whole square phi m square plus root 3 by 2 whole square phi m square plus 2 into AB, right? Minus 2AB, cosine of the angle between those two. So how much we are getting? Root 3 by 2 whole square phi m square into 3 we will get, right? So if you apply the square root, root 3 times root 3 by 2 phi m, it is root 3 into root 3 is 3 by 2 phi m. So it is in the 3 by 2 means 1.5 times phi m is the resultant value. 1.5 times phi m is the resultant value. At what instant? At theta equals to 0 degrees. Similarly we will do for at theta equals to 60 degrees. What we have to do is, in the same equations, in these equations, in the place of omega t, now you will substitute 60 degrees and you will calculate. So sine 60 is nothing but root 3 by 2. So now at theta equals to 60 degrees, the theta 1 value is how much? 3 by 2 phi m. 3 by 2 phi m. At theta equals to 60 degrees, phi 2 value will be minus root 3 by 2 phi m. minus root 3 by 2 phi m. In the same equations here, now we will substitute for phi 2 value 60 degrees. 60 minus 120, right? Minus 60 degrees we will get. Sine of minus 60 degrees, right? Sine of minus 60 root 3 by 2, right? Minus root 3 by 2, minus root 3 by 2 phi m. So phi 3 value will be how much? 0 degrees. Why? Because 60 minus 240, right? So here the resultant value again 2 times root 3 by 2 phi m cos 30 degrees, which is equals to the 3 by 2 phi m. So like this here at another instant also at theta equals to 60 degrees. Now the diagram has changed. Which one is made 0? Which one is made 0? Phi 3 is made 0. Phi 3 is made 0, or not made 0, it became 0, right? So phi m value is positive, phi 2 value is negative. That is what we have done here. Phi 1 value is positive, phi 2 value is negative, minus phi 2, because the actual value of phi 2 will be here like this. This is phi 2. Its opposite will be minus phi 2 with reference to this point. So this angle will be 60 degrees. Now the resultant value, how we will get the resultant? So this dotted line, extend this dotted line which is quite parallel to minus phi 2. So this is minus phi 2 and this value is phi 1. Now again same apply the law. So we will get the resultant value as 3 by 2 times phi m. 3 by 2 times phi m. Like this at different positions at theta equals to 120 degrees and at theta equals to, now at theta equals to 120 degrees, theta 1 is root 3 by 2 phi m. Now phi 2 becomes 0, phi 3 is minus root 3 by 2 phi m. So here that is what we have done here. Phi 1 is a positive value and phi 3 is a negative value. Phi 2 is not there. Phi 2 is not there. Flux 2 is not there. Now this is our resultant value. Similarly at 180 degrees, at theta equals to 180 degrees, which two values are present? Phi 1 is became 0, phi 2 is root 3 by 2 phi m, phi 3 is minus root 3 by 2. So phi 2 we are having a positive value, phi 3 it's a negative value, right? We will this reference point 0 and phi 1 is not existing, right? If you want you can now resultant of these two vectors, we should draw a quiet line parallel to phi 2. This is phi 2 and this is represents minus phi 3, right? The resultant is this one. This is the resultant value phi r. This is the resultant flux. The angle between these two is 60 degrees. On substituting and doing the calculations, we will get the again the resultant value is 3 by 2 phi m. So whatever is the position or angle theta, even though we are having three individual fluxes like this for phase 1 and phase 2 and phase 3, but the resultant value of the flux at any instant is equals to how much? 3 by 2 times phi m. 3 by 2 times the phi m, where phi m indicates the maximum value of the flux. For example, in this diagram, this peak value represents the maximum value. This is the peak value is the phi m, maximum value of the flux, right? If we can observe in this diagram also, at this angle difference between phase 1 and phase 2 is 120 degrees, up to here 90 plus 30, this is 30, 120 degrees. Once the phase 2 has started, again the difference between phase 2 and phase 3 will be again 120 degrees. Like this we have to draw the waveforms which are displaced by 120 degrees, right? So here the resultant value of the flux is 3 by 2 phi m, that is 1.5 times the maximum value of the flux, and the resultant flux, this is the flux which rotates round the stator at synchronous speed, that is nothing but ns equals to 120 f by p. So far we are drawing diagrams like this, where this is the stator and we are having the rotor, and in this gap the flux will be this is the resultant flux phi r, which rotates phi r, right, which is nothing but the 1.5 times the phi m. will be rotating at what speed? At a synchronous speed. That speed value is given by 120 F by P. 120 F by P. So this is what about the generation of rotating magnetic field. So in this entire discussion, the key point is the resultant flux is the vector sum of individual fluxes. The individual fluxes are mathematically given by phi 1 is equals to, because they are sinusoidal in nature. Because they are sinusoidal in nature, this is the sinusoidal equation. This is the graphical representation. This is the mathematical representation of a sinusoidal waveform. For example, if this is the graphical representation, what is the mathematical representation for this one? This is a line passing through origin. So this is x-axis, this is y-axis. For this such kind of waveform, what is the mathematical representation? Y equal to mx is a line passing through origin. This is the mathematical equation. Similarly, the flux is sinusoidal in nature. Because of that, we have taken its mathematical form as phi 1 equals to phi m sin omega t. This is important. Second flux due to phase 2, sin phi m sin omega t minus 120. At different values of omega t, we will calculate phi 1, phi 2, phi 3. For resultant value, we will apply this parallelogram law and we will add up, and result finally we will get 1.5 times phi m, right? Thank you.